Write a Java program to check if a given number is a prime number. A natural number greater than 1 which has no other divisors except 1 and itself is said to be a prime number. For example, let us consider the number 2. The divisors for this number is 1 and 2. Likewise, for the number 3, the divisors are 1 and 3. Some of the prime numbers are 5, 7, 9, 11, etc. So for the number 5, the divisors are 1 and 5. For the number 7, the divisors are 1 and 7. For the number 9, the divisors are 1 and 9. And for the number 11, the divisors are 1 and 11. So for all these numbers, we have got only two divisors which are 1 and the number itself. So these numbers are called as prime numbers. So other natural numbers like 4, 6, 8, 10, etc. are not prime numbers because for the number 4, the divisors are 1, 2, 4, and for 6, the divisors are 1, 2 and 3. For the number 8, 1, 2, 4 and 8. And for the number 10, 1, 2, 5 and 10. These numbers have got other numbers other than 1 and itself as their divisors. So these are not prime numbers. Now let us look at the program which will check if a given number is a prime number. This is the program. Within the main method, we are getting the number from the user for which we are going to check if it is a prime number or not. Now that number is stored in a temporary variable. And then we are dividing the number from 2 to number divided by 2 to check if it is a divisor of any other number other than 1 and itself. That is, if number divided by some value is equal to 0, it means that this value is a divisor of number. So the value of count will be incremented. Now we are not checking if 1 is a divisor, and also we are not checking if the number is divided by itself. So other than these two, if there are any other divisors for the number, it will not become a prime number. So in that case, the value of count will be incremented, and at the end of the loop, we will check if the value of count is changed. If it is changed, then the else part will be executed where the number is not prime will be printed. If it is equal to 0, then it means that no other value is a divisor of the number and hence the count value was not incremented at all. So that is why the value of count is still 0 and the statement this number is a prime number will be printed in the output screen. Now let us check if our program is correct. First let us compile the program, that is javac prime.java. Now the program has been compiled and the .class file would have been generated. Now we can run the program, that is Java prime. The user is asked to enter the number. Let us enter the prime number, say 2. The result is 2 is a prime number. Let us check for another prime number, say 3. It is also a prime number. Let us check for another number which is not prime. For example, 10. 10 is not a prime number. So our program is working correctly. Now let us manually work out the program to understand the logic. The number entered by the user is suppose 7, which is also a prime number. Now this number will be stored in the temporary variable, and then let us start the execution of the for loop, that is iteration number 1. Here the value of I is equal to 2, that is the value of I is initialized to 2, and then we have to check the condition if I is lesser than or equal to number divided by 2. The number entered by the user is 7. When 7 is divided by 2, we will get the result as 3. So when I is compared with 3, that is 2 is lesser than 3. So this condition is satisfied and the loop will be executed. Here we have to check the condition if the number when divided by the value of I gives the remainder 0. Now the number given here is 7. When divided by 2, it does not give the remainder as 0. So this loop will not be executed. Now let us move on to the next iteration. Here the value of I has been incremented to 3. When checked with the condition if it is lesser than or equal to number divided by 2, which was 3, 3 is equal to 3. Still the condition is true and the loop can be executed. Here we have to check the condition if number when divided by the value of I gives us the remainder 0. Now the number is 7. When it is divided by 3, we do not get the result as 0. So this condition is again false and the loop will not be executed. Now let us move on to the next iteration. Here the value of I has been incremented to 4. Now when it is checked whether I is lesser than or equal to number divided by 2, which was 3, 4 is greater than 3. So the condition is not satisfied here and the loop will not execute. It will terminate here. Now as a result of these iterations, the value of count has not been changed and it is still 0. Now let us check the condition if count is equal to 0 and num is not equal to 1. Here the value of count is not changed during the iterations. So this part of the condition is true and the number, which is 7, is not equal to 1. So this part is also true. The logical AND operation is used within the if condition. So only if both the conditions are true, the entire if condition will be satisfied. Since here both the conditions are true, this condition is satisfied and now the if loop will be executed where the number, that is 7, is a prime number, will be printed in the output screen. Now let us check for another number which is not prime. Let us take the number as 10. Now let us store the number in the temporary variable. So temp is equal to 10. And now let us move on to the first iteration of the for loop. Here the value of I is initialized to 2. When checked with the condition whether I is lesser than or equal to number divided by 2, the number given here is 10, which when divided by 2 will give the result as 5. So the value of I, that is 2, is lesser than 5. So the condition is true and the loop can be executed. Here we have to check the condition if the number, that is 10, when divided by the value of I, that is 2, gives us the remainder 0. Now the number 10 when divided by 2 gives us the remainder 0. So the condition is satisfied and the loop will be executed. Within this loop, the value of count is incremented. Now the value of count is equal to 0 plus 1, that is 1. When the break statement is executed, the loop will stop executing. The loop will terminate here. The next statement of the program will be executed where we check the condition if the value of count is equal to 0 and number is not equal to 1. Now the value of count has been changed to 1. So this part of the condition has become false and the number, which is 10, is not equal to 1. So this part is true. Now the logical AND operation is given here. So in such a case, both the conditions must be true for the entire if condition to become true. So here one of the condition is false and the other is true. So the result of this if condition is false and hence this loop will not be executed. The else part will be executed where the number, that is 10, is not a prime number will be printed. So this is the logic of the program.